Welcome to Lecture 8 of an Introduction to Computer Science with Python. Today we learned about the bool data type, which is like int or string, and also related to that, the if statement, else next time, if you know what that is. So just a quick backstory on how coding works. There are generally three sort of ways that coding can do something. One of them is sequential, which is to run lines one time at a time. To run one line at a time. This is what you're used to. For example, if I said x equals 5, print x, what Python's doing is that it's taking this first line and doing something with it, and then it's taking this second line and doing something with that. It's doing one line at a time. The second way is called iterative, where you run lines a set number of times or until something becomes true. For example, if I wanted to print x 5 times, you won't need to know this yet, but I would do something like this. This will print x 5 times, but I don't want to focus on 4 right now. I want to focus on something else. The third way is called selection, where you run a line or lines once if something is true. So if something happens to be true, then you're going to run a group of lines. And today we're going to learn about this last one called selection. Putting it into code is usually done with something called the if keyword. And when you have the entire thing, which includes the if part and the block of code that you want to run, if something is true, those two things put together is called an if statement. Before we do that, we have some other things to cover, and that's going to be mainly this thing called bool. Remember that a data type, or data type, depending on how you want to type it out, is a way of storing information. For example, also known as data. So for example, 5 is data, and I can store that into a variable called x, or y. Oopsies. I can store it into y, or z. But 5 is a data type, is data, and its type is int, because it's a number and it doesn't have quotation marks. This is a string. This is an int. Those are the only ones that you know for now, but that might change very soon. A Boolean, a variable or expression, can be one of two values. It could be true or false. And they'll be useful when you make if statements, because it tells the if statement whether to do something or not. Again, see the previous slide for reference. So if you want to create a Boolean from non-Boolean or bools, these two are like the same thing. Make a Boolean from expressions or variables that aren't all Booleans. One expression, similar to how int has a function where you can take x equals int of a string that happens to be a number, like this, then you can print x. The thing is that this looks the same. However, if I wanted to add 1 to it, I can now make x add 1 to this thing. I can now add 1 to x and then print that. Now it prints 8, 2, 3, 1. But you can't do that with just a normal string. For example, if I were to comment this out and say x equals int, actually just 8, 2, 3, 0, then you can see there would be a problem, because Python doesn't know how to add a string and a number together. But it does know how to add an int and a number together. That is because int and numbers are the same thing. So int, number, whatever, they're all the same thing. So it can add an int and an int together, and it knows how to do that. So this is how you change the type of an expression. That being said, you can do the same thing for bool or Boolean, but Python prefers bool. See how it turned green? Bool of something, usually numbers, but we'll see in a second. So bool of some expression or variable converts the expression to true or false. Bool of 0 is false. Any other number is true. Bool of an empty string, where you just have 2 quotation marks next to each other, that's false. And any other string is true. For example, if I said, so if I said bool of 0, that's false. Bool of any other number is true. if I said bool of an empty string, this should give me false. And a bool of some other string, I think it's true. You can do a similar thing with just having a space. It's not an empty string, so it is also true. If you want to make a Boolean out of two expressions, this is going to mainly focus on equals equals and exclamation mark equals. So comparing two expressions, this is like the first way to compare two expressions. To see if the two are equal, use equals equals. That's because equals, where you only have one equals, that's already being used for something else. What that something else is, can you try to guess? That something else is variable assignment or variable making. X equals 5. And Python will get confused if you try to compare two things without making a variable. To see if the two are not equal, you can use exclamation mark equals. And if the two expressions are different types, be careful. For example, you might want to be careful when comparing an int and a string. For example, you can do 5 equals 5 to check if 5 is equal to 5. But 5 equals string 5, you have to be careful because this should give you an error. But since they're not equal, according to Python, this is false. So yeah, do be careful with that. More on comparing two expressions, you can have less than, greater than, less than or equal to, and greater than or equal to. These are primarily for data types like int, where you can tell, oh, is 5 less than 6? Of course. But they can be used on string if you know how, and strings if you know how they work. Because you can do less thans, like A is less than B is true. But C is less than B is going to be false. But if you don't know how it works, don't worry about it. However, if you want to learn more about it, it's called lexicographical minimum strings. I believe, something like this. I'm not sure. But it doesn't matter because you probably won't be dealing with anything like that. You'll probably be converting it to int either way. But less than, these should be familiar from math class, by the way. Less than 5 less than 6 is true. 6 less than 6 is not. Greater than, same story. Less than or equal to is a bit interesting because it takes the two numbers and first checks if the first one is less than the second one. And if not, it then checks if the first one is equal to the second one. And if not, then it's false. But if it was less than, it was true. Or if it's equal, if the two expressions are equal, then it's also true. Same idea with greater than or equal to. I've just put these symbols because these are the stuff that's used in math class, and you might recognize those. You can also create a Boolean from other Booleans. So if you want to flip a Boolean from true to false or false to true, you can use the keyword not. For example, not true and not false. Otherwise, you would probably, of course, you would probably substitute true and false for actual variables. So like I say, if have a passport equals true, because I do have a passport. And then we can experiment more with that later. But if I want to say if actually not have a passport, this whole thing would be false. You can also combine two bools using, you can combine two bools using and or. So and checks the left and right Booleans. For example, the way you would use this is like A equals true, B equals true, A and B. This is how you would implement the and keyword. You have two on the left, you have one on the left and one on the right. If both are true, if the left and the right are both true, then the whole thing is true. So in this case, A is true, B is true, so this whole thing is true. Or, which is another keyword, checks the left and right Booleans. And if one or both are true, the whole thing is true. So here, A or B, this is true because at least one of them is true. But if I made B false, then this would still be true because at least one of them is true. In this case, A, one or both. So now we get to the important part with an if statement. So this is going to be, I actually had an idea earlier about having a passport. Have passport. Let's say I do have a passport. I want to say, if I do have a passport, then I want to print you can travel. And if I don't have a passport, I want to print you cannot travel. So the way I would do this is that if have passport, print you can travel. This is all we're going to do for now. So then I can say something like, instead of having a variable that just is true, I can ask for an input. So if I say, oh, this is going to be a bit complicated, but you'll get to see many if statements. So first I want to get the raw data, the raw input that somebody's going to give me. So passport equals input. Do you have a passport? Y for yes, N for no. Then I can say if okay, so then I can say so I got the input. I'll put a space out here. If passport is equal to Y, then have then have passport. I'll have passport default to false, but if I do have a passport, then have passport becomes true. So in this case, by default it's false, but if it's Y, meaning it's yes, then it's true. And now I can say if have passport, you can travel. So do you have a passport? Y for yes, N for no. Let's say I don't have a passport, N. Nothing happens. That's okay. But let's see what happens if we do have a passport. I type Y for yes, and it says that I can travel. That's basically how if statements work. Now let's say I wanted to make it better. So let's just focus on the end here. I can say if not have passport, this is what I sort of had before, print you can't travel. So now if I say N for no, it says I can't travel. In fact, if I put in anything, it says I can't travel, unless if I put Y. In the case of Y, it says that I can't travel. So first, it gets the input as a string, and then we create a Boolean called have passport and set it to false by default. But if the string of input, if that is equal to Y, we want to make this have passport value true. And now if we have a passport, print you can travel. And if we don't have a passport, we can say that we can't travel. Also, I had like this complicated thing. Can I eat a cookie test? Basically, it takes a number from the person that's typing in things, and that number is the amount of cookies left in the cookie jar. And if that number is greater than or equal to 1, then I can eat a cookie. After I eat it, I should update the number of cookies. Then I should print that number so the user knows the new number of cookies in the cookie jar. Also, I wanted to note something, and this is brand new because we've never done this type of thing before. It's called tabbing. You'll notice on your keyboard that tab is right above the caps lock or the search thing. It's on the left side. It's next to Q as well. And what it does is that it makes these spaces. And right now I'm pressing tab. And these tabs tell Python what is inside the if statement and what is not. I'm gonna skip ahead to the next slide so that we can see like a graphic. This is just from a programming, where you learn programming. It's called Scratch, and it says when the green flag is clicked, if the space bar is pressed, then move 10 steps. In this case, move 10 steps is a line that has a tab in front of it. In this case, it's represented by being inside this block, but it has a tab. So even in a beginner's language, you have to know, you have to know what happens if, how do you know if this should be done if this is true? This is how Python tells. You have like this tab thing here. That'll be probably the end of the lecture actually. But if you're interested in this cookie thing, it's not that hard to do. So I recommend, as a little brain tease, if you like, before the next lecture, it might be fun to try this out yourself. It'll also give you a chance to actually type things out instead of listening to some high schooler rant about coding. Anyways, that'll be it. Thanks for your attention. I will see you next time.